away so that I can guide you through it straight away. All right, as you can see, I just wrote review of Year 11 content, right? Because it's not really Year 12. Maybe even for some students it would be Year 10 content. So if you had f of x minus a, if you have a attached to the x, we shift to the right by a units. So it's minus a, we go to the right, it's plus a. If it's x plus a, we shift left by a units. If it's not attached to the x plus a, we shifts up by a units, and if it's minus a, we shift down by a units. The word that you use in Year 12, in inverted commas, is translate. We translate to the left, translate to the right, translate up, translate down. Are you going to hear me say translate? Very unlikely, unless we're going to change languages. You're going to just hear me say shift left, shift right, shift up, shift down. No translations. Reflections, something that you might already know. If the negative's on the outside, just like this, what happens to your negative of the whole thing? So negative of f of x. Flip or reflect, as you can see the word that they use, about the x-axis, so you're flipping down. If it was negative x, it's actually a flip or a reflect, however words you want to use, about the y-axis. That means if you had something like this, and if I did negative of x, not negative of f of x, negative of x, it will look like this. So this would be f of negative x, this would have been the original. Usually very poorly done. So it's very easy to say yes, Tiana, it is very easy, but it's very hard to actually teach it. So what you want to do is, I guess, get to a point where you can spit that out to me or to your partner or to your mom or your dad or whoever it is and explain it to them. That's when you can say, yes, I get it. Because a lot of students mix up those two specifically. Okay, easy. Then we've got what is called a stretch, or what's the fancy word they use, Sabine?
Dilation.
Dilation. Yeah, so again, we don't use the word dilation, or I don't, in my everyday language, so I'm not going to all of a sudden say, hey, dilated. But whatever. You can use the word dilation, that's the word you get used to in Year 12. In Year 11, I used to just probably call it a stretch. If the A is attached to the X, Sabine, help us out. Yeah, good one, huh?
Yeah.
You got a 50-50. You know what the first word is, right? Yeah, you're tossing up between. Do you know what the words are?
Either
Yep.
horizontal or vertical.
Yeah, it's either horizontal or vertical. All right. This one, because this would look like this. This is the way I see it, right? If you put a 2 in front of it, it will look like that. I always bring it back to a parabola. If I know my parabola, I know everything else. Everything else. So what would that do to a parabola? It just makes it actually shoot up faster. So that means it just changed it from, how can I say this to you guys? It changed it horizontally. I mean, that's the only way I can say it. It changed it from left to right, like the width. The width, yes, that's a good word. The width is changing. Can we see that? Because it's got thinner. So you would say this is a horizontal dilation. You see how a horizontal stretch or dilation. You see how Sabine's learnt it. She's done an assignment on it, and yet between the two, she's mixed it up. And that's normal. And that's what I was just telling you, Tiana. I was like, as much as you can say yes, because it does make sense, it's got to get to a point where you're able to teach it. And look what I just did. I might forget as well, but I just did it for 2x squared, and I think about, okay, what just happened to 2x squared? Well, It actually was a horizontal dilation, whereas this one, obviously, once you know the other one, this one's a vertical stretch or dilation. So that means, just so you guys understand, if it's horizontal, it means what letter is it? What out of x and y, because x coordinates and y. If it's a horizontal stretch, what's it going to impact? Your x or your y? If it's a yeah, you're not wrong. I'm just thinking, what was I thinking in my head? No, but you're right. It is right. Horizontal would be x's. Vertical dilation should be y. Maybe I should check this in case I'm getting the wrong 50-50 wrong. So Ben, can you check on your assignment real quick?
Yeah, wait a second.
Just double check. Am I getting the two wrong? In my head, it sounds right. I just don't want to get it wrong right now since we're here. Can anyone confirm that? Joey, what about you? You've done this.
Right.
It's right? In my head, it sounds right. But we all make mistakes. Horizontal, x's and y's. That's how, I mean, x's, sorry. Vertical, I think of y's. So I just want to make sure that a of f of x is a horizontal stretch and f of a of x is a vertical stretch. Found it, Sabine, or not yet?
I'm trying to see, but if it's vertically dilated,
Yeah.
um,
It's affecting our x's, isn't it? Yeah.
oh, I think so.
Is
Yeah,
it vertical? Say again?
if it's vertical,
Yeah.
it's changing the x value.
Yeah, I actually thought so. And the horizontal will be changing the y's. Yeah? Am I right?
Yeah.
Yeah. How does that work? The best thing is to actually see it on a graphic calculator, but if I was to give you x plus 3, just a straight line. If I gave you a straight line, x plus 3 is somewhere like this. If I multiplied the whole function by 2, yeah, what happens to this guy? Yeah, no, well, no, yeah, technically, there's a y-intercept obviously. It multiplied by 2. You don't want to say up because up means translate or shift it up or whatever. So yeah, it got multiplied by 2 as well. Now, you might say the x value got multiplied by 2, but if that x value was 0, it's still at 0. And that's how we think about it. Now, that's why I stopped. In my head, I was like, horizontal sounds right for x, but I think it's the opposite. So there you go. We just learned something altogether. Let's do the opposite. So if it's a stretch, it's the opposite of the word you might see. So if it's a horizontal stretch, you would say it would actually change the y values. If it's a vertical stretch, you're going to say it changes the x values. Don't confuse that with shifting up and down. Shifting up and down stays the same. If you shift something up, obviously your y values change. You shift something to the left, your x values change. Okay. Okay. We will see. And then you can combine them all. All right. Done. So here's a question, an exam question that you would see in your exams. So whoever's got exams, this is pretty much the style of questions that you'll get. The point P, 4 and negative 3, lies on the graph of a function. The point 4, x is 4, and negative 3, somewhere here, lies on the graph of a function. The graph f is translated 4 units vertically up and then reflected in the y-axis. So look what I've done. Go 4 units up. You know I'm right here, 4 and 1, and then reflected in the y-axis. So that means it's at negative 4 and 1. That was easy? Good. Next one. If the equation is true for all values, then the rule for f could be f of 2x minus 2 of f of x equals 0 is true for all values of x, and the rule for f could be a function. Okay. All right. Again, another good one because it's different. You saw I had to read it again just to make sure. Has this got anything to do with what we just did? No. It's got nothing to do with what we just did, unless you can see it, unless you understand it, which I don't think you guys do. Right? You don't need to, is what I'm trying to say. I don't think anyone at high school level needs to just yet. So I'm saying this is the theory of it. So this is like your, what do you call this? A vertical dilation or vertical stretch, horizontal stretch. Why? Like why do you want to, and then you've got to understand that when they subtracted, they equal to 0. Too complicated. Do this instead. What does f of 2x mean to you? F of 2x. No, that's actually incorrect. That's 2 times f of x. That's this one. What you just said. But that's okay. You don't need f. What does it mean to you? What would you usually do? Yes. Can you say it a little bit better? That's not what I would usually say if I said f of something else. You're overthinking. Don't forget this question. Just think if you've ever in your life, up to where you're at, you've seen f of and then something in brackets. What have you used? Sorry? Yeah, f of x is y. What have you usually done? Thank you very much. That's how you do these questions. Come on, you guys are getting closer and closer to the HSC, right? Every time you get a step closer, you got to start thinking, well, I kind of know everything now. You are. Everything you've learned in year 11 is going to get repeated in year 12. It's not going to be anything new now. So just be careful with that. Cool? So when you see that, I would hope you would just say, hey, let's just sub it in. So I'm going to sub in 2x into here. For a, what's it going to look like? 4x squared on 2. All right, you're subbing in x as 2x. Come on, I'm not doing anything. 2, f of x. F of x is this. Does this become 0? No, because we just saw that became 4x squared on 2 minus 2x squared on 2. Does not become 0. So A is wrong. B. You're going to sub in 2x into x, so it's going to look like this. Oh, does this become 0? 2 times x minus 2 times f of x, which is 2x anyways. And that just becomes 0. So the answer is, sorry, I wrote B. The answer is C. Done. Has nothing to do with this topic. Move on. Okay. The transformation that maps the graph of this on the graph of this is A. So how do you get from here to here? What has happened? All right, let's think for a second. Just wait. Let me also think. Okay, I can see x has to become that, and it is a, okay. Can we see that the, obviously everything else is the same except x is x cubed here, whereas this is 8x cubed. Yep. So that means I've done something like this. I've changed my x value inside. Can you understand that? Because my x value is changing. Yes? So what is x equal to? What would x equal to? F of what? Well, it should have been f of half x. Because what's a half cubed? What is a half when I sub it in? 1 over 8. And then the 8 and the 8 would cancel out. And then you're left with x cubed plus 1. Do you get that? Yeah? So, and we know these ones were called horizontal or vertical? Vertical. Now, something I haven't said yet, if it's a vertical dilation, it's actually a factor. You say it says dilation by factor of. It is the reciprocal of what you see. That's the only thing you actually need to know. Only for vertical. So if A is a half, what's the reciprocal of a half? 2. So it's actually a dilation by a factor of 2, which means this is wrong, this is wrong, this is wrong. Now, is it the y-axis? Is it from the y-axis or from the x-axis? Vertical from the y-axis. Yeah, the x values are changing, but the y values are. I'll draw it for you, like I said, on Des wants to show you. I actually have Sabine's assignment. I was going to give it to everybody because I think it's a fairly simple, good assignment to just show you guys the step through transformations. So I was actually going to give you guys that as an exercise to do for graphs anyway. Everyone's thanking you, Sabine. They're not thanking me. Find the value of A. All right. And there's more. How do we find this? Just out of curiosity. He said find the A. And you're given the graph. Too slow. Wrong. Sub in quick. Again, try again. If I want to find this literally.
Y equals 0.
Bingo. You're going to make y equal to 0 because that is just called the... No. X
Value.
X-intercept?
intercept. That's called the x-intercept.
That was my next guess.
That was my next guess. All right. Well, I'll leave that one. Let me see. Is there any more? No. Okay. Hold on. Let's stop this recording.